Hi, everyone. It's great to have you join us today for our session, How New Technology Can Improve Utility Vegetation Management, which is being sponsored by AI Dash. My name is Jen Runyon, and I'm a content director here at Clarion Energy, and I'll be your moderator for the session. Today, we're going to hear from Nitin Das, who's the Chief AI Officer and co-founder of AI Dash, and we're also going to hear from Bradley Smith, the Senior Director of Sales at AI Dash. Okay, that's it. We have a short time here, so I'm going to get started. I'm going to turn it over to Bradley Smith, the Senior Director of Sales at AI Dash.
Awesome. Looking at the time, it looks like some of our slides showed up a little bit weird too. It looks like they might be rendering a little bit oddly, but we're going to be talking about kind of some other different emerging technologies that are enabling new data-driven vegetation management tactics. So I'm going to be quick throughout this part because we have a couple of videos that we also want to show. But we'll go over kind of like what vegetation management is today, kind of how people are using predictive encroachment models using weather and species, kind of data-driven vegetation management, and what are the best practices there, and what components are needed to do it correctly, the latest satellite technology, and then that satellite technology in practice, and kind of showing you, because some people just believe it to be Google Earth still. So vegetation management today. I mean, everyone knows it's kind of manual, repetitive. You don't really use a lot of technology. Eric was mentioning too how they just recently started to use technology for their program. It's something where it's kind of a later adoption curve on this type of new technology that now exists. So without that kind of holistic insight, you're spending one of your biggest line items on this. I mean, without kind of fully understanding where to most advantageously deploy your resources, kind of surgically. And it's kind of like speaks onto the scale of this problem. And then there's some organizations that are doing predictive encroachment using non-actuals. So they're kind of measuring variables that will impact a variable that will impact encroachment rate. So, there are some organizations that are using weather-based models and species growth rate, but there's also these micro variables that impact it. I mean, what's the competitive interactions in that little environment? What's the, is there a road nearby? Like, is there a lot of traffic? I mean, there's so many little different things, the topography, the gradient, the percentage of clay versus coarse sand, the depth of the bedrock. There's so many micro variables that go into place when doing it. So it's kind of an imperfect, inaccurate, time-intensive type study, and it really doesn't take data and turn it into insights that are driving action. So we think of vegetation management of these type of core components that are needed to be able to do this properly. And that first component is getting that 360-degree view of your entire network, not just a subsection of your network. I mean, yeah, you probably want to focus on those fire dangers as a little bit more than just the entire network, but you need that entire holistic 360 view of your entire network. Your budget isn't just isolated to one segment, one circuit, as for your entire network. Let's improve reliabilities holistically across the whole thing. So gaining this 360-degree view, you can't really gain it unless you correct that GIS data first. It's so common that you're like, there's a pole across the street or something like that. I mean, you have to be able to correct it if you're predicting what the current and future states of it are against your actual lines. So correcting that GIS data is step one. You have to detect the clearance both horizontally and vertically. I mean, that's one of those things where you have to be able to do that. Detect hazard trees. Fall-ins occur more than grow-ins. So getting that kind of, that's a needle in the haystack. There's almost 7 million miles of distribution and transmission lines in the U.S. alone. So that's a needle in a haystack times a million type activity when you're thinking about it. And then also, again, calculating that growth rate. So there are different techniques to be able to do this. I mean, satellite, drone, area, I mean, you go into like all of these different things. And the resolution for all of them are about the same. I mean, good enough to be able to do it. LiDAR is super granular. Like Eric was mentioning, I think they said 6 centimeters. For satellite is 30 centimeters. Still, like very granular. Like you can get this to be very, very high resolution. And also when you think about the multispectral aspects too, there's a lot of information on satellites that you currently can't have when you attach it to a drone or a helicopter or put it on top of an automobile. And again, one of this thing is your entire network. Taking a drone, this might be 10 miles a day max, maybe. It takes a while to be able to analyze it. If you have 100,000 miles, that's almost 3 years to collect all the data. Satellite, you can do it instantly across your entire network. Apply all of this stuff, do that change detection. I mean, Eric, they've been doing that change detection with LiDAR. If you're starting this now, you can't put a time machine on a LiDAR and run it in the past and do the change detection back then. It's something that you can start now and measure in the future, but you can't do it retroactively. With satellite, you can. You can do all of that, and the price point also. when you're talking about reducing costs, improving reliability, it's that multi-factor high yielding activity. So reducing costs is one of those things that has to be core to what data-driven vegetation management does. So when you think about that, satellite costs aren't that expensive. Satellites are already up there. Just need to take the pictures and analyze them. But then when you're thinking about all of this too, it's not just, hey, we're making all of our decisions based on just vegetation encroachment alone. Like you wouldn't just be isolating the way your business runs based on one variable, one factor. You'd be thinking about it from a ton of different factors. All right, I got stuck for a second. So, I mean, like, what's the customer's impact? And what's the downstream impact? I mean, like, what is it going to be impacting on your frequency of interruptions, duration of interruptions? I mean, workload, current, like, I mean, there's so many different things. If everything was alike, you would weight it differently based on these different variables. So you have to combine all of this data because, you know, remember, it's like data-driven vegetation management is turning raw data into insights, into actions, into results. This is a great quote from Warren Buffett: predicting the rain doesn't count, building the ark does. And it's one of those same things, like insights for insight purpose aren't really great. You have to turn this into action. You have to turn this into results. So doing all of this, you have to be able to, I skipped ahead, analyze, provide actionable insights that are easy to act upon, and then increase efficiencies using automated workflows. I mean, you have to do all of that. I mean, data into insights, into actions, into results. So what to do, when to do, where to do it. Like, I mean, do you need to deploy a bucket truck? You need, I mean, like every single little different thing, you need to be able to determine all of this and act quickly. And again, I mean, like one of the things is, this is just, turning data into action is one thing, but validating that this has happened. I mean, in 2016, 77% of utility arborist hours were outsourced. I mean, you have to be able to do that post-term inspection quickly, efficiently, and be able to verify results are done. I mean, let's make it quantifiable. Did you do it? Like, let's figure it out. And then again, the pervasiveness of disasters too. It is becoming more and more ubiquitous and commonplace. I mean, the frequency of hurricanes just alone in this year, I mean, it's the largest hurricane season on record by far. 28 named storms, 12 made landfall in the US, and then a ton of other different disasters too. So these widespread weather events or natural disasters, you have to be able to survey disaster quickly and deploy crews advantageously in the most optimal fashion possible. I mean, when you're thinking about like, this is a boiling the ocean activity. If a big hurricane comes in, your entire system is changed. What do you do? Where do you put your chips? I mean, you have to be able to know where to put your resources. So all of these components kind of have to be in place to be able to do vegetation management optimally. I mean, if you don't have every single one of these in place, then you're only looking at it from one slice. I mean, this is opportunity cost too. So again, like, reducing cost, increasing reliability, decreasing customer interruptions too, increases revenue because you're keeping the power on. So this is a really high yielding activity that you can get right. And then we're going to be talking about kind of the latest satellite technologies that are enabling this to happen. So Nitin, over to you. And sorry if I was really quick. We'll share the slide deck later. So
thanks, Brad. So as Brad mentioned, the satellite technology, there are two kinds of satellite data. One is the multi-spectral satellite data, having an optical bands, as well as there are multiple bands, something like a coastal band, red edge band, which helps in determining the vegetation health and other important features we can capture through the satellite image. The other is basically the other satellite type of data is basically the synthetic aperture data. The problem with the optical satellite data or the multispectral satellite data is it is hard to capture when there is a snow season or a cloud in the atmosphere. So it's very, very difficult. So in order to basically handle that kind of situation, synthetic aperture radar is a satellite which is agnostic to ice and all those things, and as well as cloud covering. So it basically emits electromagnetic waves and basically captures those waves and use that in capture information to calculate various factors, something like a height detection, the minerals in the soil, and it can penetrate 1 to 2 meters beneath the ice as well as the soil. So it works in various band expanse even, having multiple frequencies and wavelength, which helps in basically extracting multiple features from the data itself. Over to you.
Thanks, Nitin. And so, we were talking earlier about like the frequency of right-of-way fall-in, like, outside the right-of-way fall-ins versus grow-ins too. It is a big problem. I mean, when we pulled this from NERC, but the average between 2016 and 2018 were 96% of transmission outages were calls from fall-ins from outside of the right-of-way. So this is one of those important aspects. We use a red edge band of spectrum, which helps detect characteristics that will that characteristics that determine tree health, orientation, all these different things. So we're able to kind of identify and pick those needles out of the haystack with a lot more accuracy. It's not a boiling the ocean activity anymore. And again, like, with this new satellite technology, you're able to do all this clearance detection. You're able to predict in the future. So it's not just isolating into what's the current state today. What do we think it is, or what anecdotally do we think it is because of our cycles? You have data to support all of your decision making and budgetary. I mean, you can back up every single dollar that you spend with data using this too. And then again, making it easy to act. I mean, you have to turn data into action. I mean, otherwise it doesn't make sense. So being able to predict this future, the future year that you need to trim based on circuit span, all this level, organize it into certain levels so your contractors can do it. You're not going to do span to span contracting. So make it really easy. Do the planning, analysis, prioritization, task creation, work assignment, review, and audit from one system. You don't need to do like a $3 million implementation of it where you connect all of your systems together. An end-to-end solution is going to increase efficiency, which decreases cost, increases reliability. It's one of those things. If you can do this end-to-end solution, your life is going to be easier. You're going to be able to achieve more with less, and then automate those workflows too. Let's keep improving this efficiency. This is a tool to help you do your jobs better and more efficiently. I mean, like, I know everyone works really hard, but using technology is going to be able to help streamline some of these workflows. And then again, validation through post-term inspection. You don't need to have a PhD in like analytics to be able to figure out what these maps mean and like turning maps into action. Like, we want to demystify it for you. If we gave you this image on the left and say, here's a change detection, figure it out, like, that's not actionable. We want to turn turn data into insights, into actions. So, we take this and turn it into a span level analysis where we say, does it meet spec? Does it not meet spec based on your exact, qualifications for those different trees and areas? And then again, widespread, weather disasters, be able to quickly task people, use that SAR imagery to go in between the clouds, find out exactly what happens, deploy your crews immediately. Before storm, to identify things that could be potentially hazards. Like, hey, we're having a big hurricane come in. Let's maybe proactively do some of these these areas to make it a little bit more efficient. I'm looking at time. We have 2 videos. So this is kind of the technology in action. Nitin, back over to you.
Yeah. So this is basically So this is a digital elevation model. So digital elevation model basically estimate the height of an object in the real world through stereoscopic satellite imagery, and the application is basically calculating the height of a vegetation, the vertical clearance between a vegetation and a conductor. So yeah, so here is basically the video So it's loading.
No, I can see it now, so I can kind of talk through it. So you can see the different gradients of color. It kind of tells you the disparity map of the height elevation of it using stereo and tri-stereoscope imagery. So you can kind of see how much granular detail you can see, like the canopy of the trees and the different tops of them. So you can, I don't know, you can continue to talk about it if you can see it, Nitin.
Yeah, I can see. So as Brad mentioned, the different colors determines different height of an object in real world. So we basically ran this algorithm around a power line. So if you look at it, this is a region of interest, and the application is basically we use this information to classify shrubs from difference between a shrub and a tree. So if you look at this region, the dark gray region is basically a small shrubs or a small tree. So we can verify through Google Street Map whether the output of a DM is making sense or not. So in the next frame, you can see that the region which we were showing in the DM was making sense, because if you look at, these are the small trees which is basically below the power lines. So that is making sense. This is one of the example. The other example is showing the presence of a mixture of a big tree, small shrubs, and small shrubs. So basically the dark part or the dark cluster of pixels represent a big tree. If you look at it, there are small shrubs and there are grasses as well. So if we look at this information in the Google Street Map, Google Street View, we can very well see that this is making sense and this is very, very correct as per the explanation. So yeah, So if you look at, if we can see, this is the representation of this in the Google Street Map. So if you look at it, there is a big tree having more than 9 meters of height. And there are basically small bushes going below the wires. And there are basically grass areas as well. So if you look at it, the dark or the gray pixels would basically determine the different height of a tree. And we can also determine the wire is going through the tree, above the tree, below the tree, and very well correctly determine, estimate the clearance, vertical clearance between a tree and a wire.
Cool, thank you, Nitin. And you can kind of see that cut through right there with like the light gray pixels on the thing and in between the two darker ones too. So yeah, and
yeah.
Now we're on the questions. So Jennifer, I don't know if you want to be the moderator for that.
Oh yeah, yep, I'm back. Yes, thank you so much, guys. It's really fascinating. You know, I drive around, now that I'm covering this industry, I drive around and look at wires all day long and think, oh, clash over there. Well, so Eric, are you still with us too? Because we have some technology questions and we have some questions for Eric. So we'll start with the technology questions. So one says, let's see, you mentioned that drones can't do everything that satellite can. Can you talk a little bit more about that?
I think that might be about us since we were talking about satellite. So unless Eric, if you'd like to take it, I'd be happy. But so cool. So some of the things that the satellites can do, I mean, that change detection. I mean, we do not need to be time travelers to be able to measure in the past. So taking that pixel to pixel differential year over year, especially if you know that, you know, if you trim a tree in year 1, it's going to grow faster than year 2. So having that actual measurement instead of like using the anecdotal information, also the speed of data acquisition too, and the geographic coverage. I mean, if you can do your whole network in one day, then you know where to put your chips. I mean, if you can only do a subsection in a day or a month or a year, then you're only going to be able to use that data to make those decisions in that one geographic area. So speed of data acquisition, geographic coverage, also price point too. I mean, when we're thinking about the reasons why you would do vegetation management and try to optimize it, it is for those cost reductions and reliability improvements. So having a cost point that actually is not going to break the bank is also really important, especially when you're thinking about the scale of you know, per line mile cost. So I think that would be, and Nitin, I don't know if there's anything that you want to add to that.
No, I think so. Apart from the growth thing, we can also determine various ecological factors like the soil condition of the soil, the mineral content, all those information we can get.
Oh yeah, and the health of trees too. I mean, with the red edge band of spectrum, we're able to detect characteristics that indicate tree health. So, I mean, those are some of the, I think, the most valuable features.
Cool, great. All right, so following in that same vein, why is that less expensive than other techniques?
Well, I can take this one too. Well, I mean, you don't have to pay for a pilot. You don't have to pay for gas. You don't have to do regulatory approvals. I mean, the satellites are already up there taking pictures every single day. So it's just acquiring those pictures. And then if you're even thinking about the timeliness, we can task a satellite to take pictures during certain like weather events. But also, I mean, we could just pull the satellites from a week ago, and then it'll be a lot cheaper as well. So it's one of those things where cost reductions can happen due to just how satellites are done. I mean, you don't need to have someone out in the field. You only have a pilot for a year doing this. You know?
And I would like to add one more point that we also process the low resolution satellite imagery, which are much cheaper than the high resolution. But we have built algorithm to basically create a high resolution satellite imagery from a low resolution satellite imagery. Yeah, so that's.
I just realized too that the slide deck got rearranged and that we didn't even do that video. So we did have a video too about how we use different algorithms and stuff to be able to crisp up low resolution image, and it's actually a really impressive video if we have time to watch it, but I'm not sure.
I don't know how we would watch it, but if it's not loaded into our deck at this time.
It is loaded. It was just disorganized, so it was behind the question slide for some reason. But right now it's actually the slide deck too. So if you're looking on.
So let me start. So basically, if you look at it, there's a low resolution satellite imagery, and we have basically used an algorithm to create a high resolution satellite imagery. So if you look at in the low resolution satellite imagery, it is very hard to detect where the tree canopy is, where the house is, the boundary of the house and all. But if you look at the corresponding high resolution satellite imagery, you can very well basically check the boundary of the vegetation as well as the tree. So here, if you look at this, it is very hard to basically determine whether it's a building or a tree or the location of each of the object. But if you look at the high resolution imagery created from the low resolution, you can very well determine where are the location of each of the object in the imagery.
Yeah, it's almost like science fiction stuff. I mean, we can measure the tree height from space. You can do this. I mean, like it's really technology is advanced where now this stuff is now possible. So that's probably the answer to our question, though. So thank you, Jennifer, again.
Yeah, thank you. Yeah, I'm glad we have it. I thought you were saying we didn't have the video, but great. Okay. All right. So I have a question. I think it is for Eric, and it's from, let me just find out where we go. Well, we could go with this one. So can you give a few use cases of performing disaster management via satellite?
I don't think that one's for Eric either. Disaster management for a satellite. Some examples. There have been recent hurricanes down on the Gulf Coast that we've done disaster management activities for. So surveying the events post storm to be able to deploy people quickly and more advantageously. I mean, this is a use case where it's not for every, like if a small thing happens, like you wouldn't want to do that. But for a large scale event where you're having spread thin assets and resources, then you should probably figure out what's going on, immediately act. So.
Cool. Thank you. Thank you so much. I mean, really, thank you to Eric and Nitin and Brad. And thank you, audience, for the questions. I also want to thank AI Dash for sponsoring the session. Bye-bye.